Sines, and eventually we're also going to learn something called the law of cosines. Now, we won't get through all of chapter 6 before the end of the year. Usually it's just 2 or 3 sections, I would say, so we'll kind of see how this goes. But we are doing quite a bit on our calculators, so hopefully you've got one. If not, I'll put mine up here and we can do some of this together. But there will be a few things to write down right off the bat here, just because this is a new topic, law of sines, something we haven't really dealt with before. Now, here's a big difference between what we've done before and what we're doing today. Today, with the law of sines, we are dealing with oblique triangles. Up until now, our triangles have pretty much been all right triangles, but now we have oblique. And this just says that an oblique triangle is a triangle that has no right angle. It's like the opposite of a right triangle. It has no right angle. Okie doke. Now, for the most part, we're going to be setting up our triangles the same way each time, and I'm going to go ahead and kind of put this sketch up here. Yours doesn't have to be that big, but this is going to be pretty important for the lesson, so I'm going to recopy this over here on the side. But go ahead and put that down, because this is like our setup for each problem. Notice there is no right angle anywhere in this triangle. And once you get it copied down, there is one other thing that's pretty important to notice. The labels. C, C, B, B, A, A. What you'll find is that the letters are sort of across from each other. Side C is across from angle C. Side B is across from angle B, and side A is across from angle A. The sides are lowercase and the angles are uppercase. That is important to notice, because sometimes in the notes and even in the homework a little bit too, they might rotate the triangle a little bit, or they might make it a little bit more slanted on one side so it looks a little bit different. But no matter what, the sides, corresponding sides, are across from the corresponding angle. So that's always going to be true no matter what your triangle looks like. Okay, now this is sort of what the law of sines is in words. And then I'll also give it to you kind of as a formula. It says that the ratios of the side lengths, and the sine of the angle across from them are equal. Again, the ratios of the side lengths and the sine of the angle across from them are equal. That is our law of sines. Now that's nice, but what I really want for my problems today is some kind of a formula to go off of. So here's what this looks like as a formula, and I'm also going to put this on the side because, again, it's going to be really important today. It says little a, I like to call it little a, over sine of big A equals little b over sine of big B, which equals little c over sine of big C. And again, the lowercase letters are the sides, the uppercase letters are the angles. So that's something to keep in mind. Now, I want to just kind of give you a little foreshadowing, if you would, of what's going to happen here with the law of sines. It's sort of in 3 pieces here, but normally when you use the law of sines, you're only going to use 2 parts at once, and it's basically going to turn into a proportion that you have to solve. So sometimes you might only be using the A's and the B's, or sometimes you might only need the B's and the C's, or it might just be A's and C's. It's not always 3 parts at once. What's kind of tough about these problems is just getting started. How do I know which parts of the formulas to use? You only use 2 parts at once. Okay, so watch carefully on our examples today, because like I said, sometimes the hardest part is just getting started and knowing how to use that formula, which parts of the formula you need. Okie doke. So here's the directions, and it says solve each triangle, round to 2 decimal places. Solve each triangle, round to 2 decimal places. We've actually had these directions before, but they were right triangles, not oblique triangles. So that is a pretty big difference. But basically, when it says to solve each triangle, you just, by the end of the problem, you just have to know what everything is. You should know what all 3 sides are and what all 3 angles are by the time you're done with this problem. Okay, so this is what example 1 gives us. It's almost just like a list of information. It says big C, that is angle C, equals 95 degrees. Big B, so angle B, equals 44 degrees. And the only side that we know is side C, not the hypotenuse anymore because it's not a right triangle, but that we know is 20 inches. Now, I don't even know what I'm doing yet in this problem, but I do see the degree symbols. So it's probably a good idea right now, before we forget to later, to check that our calculator is in degree mode. That will have an effect on what your answers are. So again, mode should be on your calculator somewhere, and just make sure degree is highlighted. All right, that's something good to do right off the bat. Now, I'm kind of a visual person, and I don't really like how this is given to me in a list. I want to see it more as a triangle, and then I can kind of understand what's happening, what I know, what I don't know. So I'm going to take this oblique triangle that we set up earlier, and I'm just going to start filling in what I know. I know that angle C is 95 degrees. I also know that angle B is 44 degrees. And little c, side C, which is across from angle C, that is 20 inches. And that's all I've got going on right now. Okay, and I mentioned this earlier, but I'm going to say it again. There will be lots of different ways to do these problems, lots of different ways to get started. I like to show you what I'm thinking, but if you think of something different and you get the same answers, that is perfectly fine. Okay, here's what my brain thinks about first. Even though this is an oblique triangle, the angles should still add up to 180. I already know angle C, and I already know angle B, so it would be pretty easy to find angle A given the other two angles. So that's what I'm going to do first. Okay, now again, this is not a right triangle. So to do this part, you're going to have to add up 95 and 44. That should be 139, but then subtract that from 180, and that gives you 41 degrees. That is angle A. One of the three things that we have to find in this triangle. I've got angle A at 41 degrees. Okie doke. That's not always the first thing that you should do in a problem. That's just what I saw first. Okay, now we still have to find little b and little a. It really doesn't matter which one you find next. Sometimes it matters, sometimes it doesn't matter. I'm going to tell you, in this problem, where we're at right now, it really doesn't matter which one you find next. I went with side B next, but again, you should get back the same answer even if you go for side A next. Okie doke. Now, when I go to find a side in these problems, I'm going to have to use the law of sines. Okay, these are not right triangles, so at no point can you use the Pythagorean theorem. Those only apply to right triangles. This is an oblique triangle. So to find a side, I'm going to have to work with this. Now, here's where we have to decide which two parts of the formula we're going to use. Now, I am trying to find side B at this point, so I know for sure I have to use the part of the formula with the B's, because that's what I'm trying to find. But now, we need to pair this part of the formula up with either the A's or the C's. And this is where you have to make a decision, A's or C's. I'm going to point you in the right direction. You want to pair that up with what you know everything about. Do you know everything about the A's? Do you know side A and angle A? No, you don't know side A, but do you know everything about the C's? Ding, ding, ding. Yes, we do. So let's pair that part of our formula up with the C's. And I've got it kind of started up there for you too. We're going to take little b over sine of big B equaling little c over sine of big C. You don't want to pair it up with the A's, because then you wouldn't have anything for little b or little a. You would have two unknowns if you do it that way. This way, we're only going to have one. So let's fill in what we can. Little b is still just a variable, because that's what I'm trying to find. Big B is 44 degrees, but remember it's sine of 44, not just 44. On the other side, little c is 20 over sine of big C, which was sine of 95. Okie doke. Anybody remember how to solve a proportion? Cross multiply. We are so lucky we get to do that a lot today. Cross multiply. It doesn't matter which diagonal you do first, which one you put on this side, which one you put on that side. I'm going to do this diagonal first. Doesn't matter though. Okay, but here's something that does matter. When I take sine of 44 degrees times 20, I can't multiply the 20 and the 44. I just have to stick that 20 in front of the sine of 44 degrees. Technically, that's multiplication because they're just written right next to each other. And same over here, b times sine of 95, you really just need to put the b out front. B sine of 95 degrees. Now, I don't know what sine of 95 degrees is, but it's some kind of a number. And so my variable is being multiplied by a number, which means to get rid of it, I have to divide by that number, whatever it is, on both sides. Now, here's where I said bring a calculator today. This is going to be something that we type into our calculator right here. Now, I'm going to put mine on the smart board up here so you can see how you should type it in. Again, check your mode. We should be in degree mode. And here I go. I like to just type in the top part first. So just 20 sine of 44, hit enter, then hit divided by sine of 95. The reason I like to do it like that is because if I type it all in at once, I would really have to be careful with my parentheses. I would have to close these parentheses before I hit divided by sine of 95. It will matter if you don't close your parentheses when you type it all in at once. I don't like to worry about that, so that's why I kind of do it in 2 steps. Now, the 6 is going to round the 4 up to a 5, so that would be just 13.95. And this is a side length. They told us earlier that side C was 20 inches. So let's label this 13.95 inches. That is one of the other variables that we needed to find. Okie doke. Any questions about how we got that one? All right. Now, what's the only other variable we don't know? A, and again, this is a 2-slider here, next slide, but this is not a right triangle, so please don't do the Pythagorean theorem. That only works with right triangles. I'm going to have to use my law of sines somehow to figure out what little a is. So I'm back over here trying to decide which parts of this formula I need. Now, I'm trying to find little a, so I know I have to use that part of the formula. And I told you earlier, pair that up with what you know the most about. And there's actually 2 options here, because we know everything about the b's and we know everything about the c's. So you could do this a couple different ways. I'm going to pair the a's up with the b's. You can see it up there. But I want you to know I didn't have to do it that way. I could have gone with the a's and the c's. That also should give you back the same answer. When you get down toward the end of the problem, you usually have more options because you have found most of your variables at that point. Okie doke, so here I go. Little a over sine of 41 degrees equals little b, which is 13.95 over sine of 44. If you have a's and c's, this part of your proportion would say 20 over sine of 95 degrees. Again, it's perfectly fine either way. Now, for me, I'm going this route. I've got 13.95 sine of 41 degrees equals a sine of 44. Now, here we go. I don't know what sine of 44 is, but I know it's a number, and it's being multiplied by my variable, so I want to divide by that to get rid of it. And I'll do this the same way I did the last one. 13.95 sine of 41, enter, divided by sine of 44. You don't have to worry about your parentheses if you do it in a couple steps. So that means little a is approximately 13.17 inches. Okie doke. I kind of filled in the triangle as I went. You don't have to do that, but it may help as you find these variables to kind of circle your answers, especially if you don't put it back on the triangle. That way you know exactly what you came up with. Any questions on the first one? All right, example 2 is quite a bit different, so hang with me. Now we have angle B, which is 28 degrees, 45 minutes. Haven't seen that in a long time. Little b is 8, and little c is 12. We don't have units here, so I don't know, inches, centimeters. We don't have to label, I guess, if they don't give us the units to start with. Now, what I want to do first is figure out this part. 28 degrees, 45 minutes. I don't like how that is written. So I want to change the minutes back into degrees. Anybody remember what we have to divide by? 60. Yeah, I'm going to show that here first. Take just the 45 divided by 60. You can just type that in. 45 divided by 60 is 0.75. So let's think of angle B as 28.75 degrees. That makes me feel a little bit better. And again, I'm going to sketch this triangle and start to fill in everything that I know. I like to see it on the triangle. Okay, so here it is. We've got angle B down here, little b right here, and little c down at the bottom. This means that I still have to find little a, and big C. So side A, and angle C. Now, I said earlier that this is quite a bit different from the first one because on example 1, we knew 2 of the angles. So it was really easy to find the third. You only know 1 angle to start this problem out, so I can't start it out the same way. It's going to be really difficult to find one of these other angles. You can't just add 2 of them up and subtract them from 180. So when I get stuck like that, then I just start to look at what they have given me. Okay, and I'm also kind of keeping this formula in mind. You've got A's, B's, and C's. Which one of these variables do you know the most about? The B's. You know everything about the B's. So I don't really know where I'm going with this, but I do know that I should use this part of my formula because I know everything about the B's. I would not pair this up with the A's because you don't know anything about the A's. Both of these variables would still be variables because you don't know anything about them, which means I need to pair it up with the C's because I at least know what little c is. Now take a look at those variables and take a look at these formulas. Once you pair these up, which variable are you going to be finding? Yeah, big C. So I labeled it that way. You don't have to label it like that, but in doing this, I'm going to be finding big C. So here we go. I've got little b, which is 8, over sine of big B, which is 28.75 degrees, equals little c, which is 12, over sine of big C. You guys told me that was the variable that we're going to be finding. All right, now cross multiply. Told you we're going to do that a lot today. I'll have 12 sine of 28.75 degrees equals 8 sine of C. Now, C is what I'm trying to solve for. I notice it's stuck with the sine, which I don't like. But first of all, before I worry too much about that, I can get rid of the 8 pretty quickly by just dividing by 8. Now, this again is something that I'll type into my calculator. So I want you to do this with me so we can hopefully get the same answer. I'm typing in 12 sine of 28.75. If you want to do all the rest of it in your parentheses, if you don't want to worry about that, just hit enter and then divide it by 8. Now, this is not my answer yet. This is still what sine of C equals. It equals that number right there. Now, because I'm not done yet, I wanted to have something to actually write down up here on the PowerPoint. So I just kind of put 0.7214 ... But if at all possible, keep that entire number on your calculator screen, and we will have one more thing to do. Okay, I don't like to round until the very end of the problem. My answer is as exact as possible if I round at the end. If you round right here, you might get back something slightly different. Okay, so back to C. C is stuck here with sine. Anybody remember how to get rid of a sine in front? What cancels out with sine? Inverse sine. Yeah, we're going to have to inverse sine both sides of that equation to get rid of the sine. Okay, so I put it in red just so you could see it better. I'm just putting inverse sine in front of the left side and the right side. Now what happens here is sine and inverse sine drop out. That's how you get C by itself. And now we need to figure out inverse sine of that number that should already be on your calculator screen. Now I'm going to show you how to do this 2 different ways. I'm going to start by hitting second sine to pull up the inverse sine. And if you have that little ANS option on your calculator, for mine I have to hit second and then the negative sign to get the ANS button. That's probably your best route. It's going to take this entire number, even past the 4, whatever it is, it's going to put all of that back into your calculator without rounding. Now, if you can't find the ANS button, you can always kind of do it the old way and just type in inverse sine of 0.7214 831534. You can type in as many places as you want, and it'll give you back the same thing, but that's just a quicker way to do it. It should be about 46.18. Now, it was an angle, so let's make sure to put the degree symbol with it. Angle C is 46.18 degrees. Okie doke. Any questions about how we found angle C? That, by the way, is really the only option to start out this example. That is the only variable that you could have found first. All right, but now that we know angle C, what would be the next easiest thing to find? Yeah, angle A. You might as well. You already know the other two. So like we did earlier, add the angles up that you know and subtract them from 180. So that is like a 74.93. Take 180 minus that, and you should get approximately a 105.07. And again, that's an angle, so it should be in degrees. Not bad. Now, what's the only other variable that we don't know? Little a, so it's a side, which means I have to use my law of sines somehow to figure out what little a is. I'm going to go ahead and do this on the next slide. Little a is what I'm trying to find, so I know I have to use that part of my formula. And here again, there's two options. At this point in the problem, you know everything about the B's and you know everything about the C's. So you could pair the A's up with the B's or the C's. I chose B, but again, you will get back the same answer if you pair them up with the C's. Looks good. So here we go. Little a is still a variable. That's what we're trying to find. Over sine of 105.07 degrees equals 8, that was little b, over sine of 28.75 degrees. If you're going the C route, this part would look like a 12 over sine of 46.18 degrees. You'll get the same answer. Here we go, cross multiply, and I'll have 8 sine of 105.07 degrees equals a sine of 28.75 degrees. So again, I don't know what that is, but it's some kind of a number multiplied by my variable. So I just need to divide by that to get rid of it. And again, I kind of do this in 2 steps. 8 sine of 105.07, enter, divided by sine of 28.75, and it should give you about 16.06. That is a side. So don't put a degree symbol, and actually you don't have to label it at all because they didn't really label the sides earlier. Alrighty, any questions about example 2? Each one's a little different, like I said, so you really have to pay attention to what they are giving you. Now this is the last example, and it should be pretty quick actually. Number 3, it's not just a list of information, it's more of a diagram. It's a triangle. You've got angle C at the top, then on the left side it's labeled 175. On the sort of right side it's 125. Little c we don't know, but I know that angle A is 115 degrees. Okie doke. So our job is to find little c, big C, and big B. There's still 3 unknowns. Now, it's important that you remember the letters or the variables. They're always across from each other. Okay, so since this is angle A, that means the 125 is side A. And since this is angle B, that means this is side B. It looks different than the triangle that we had over here, but as long as you remember they're across from each other, then you should be good to go. All right, so what variable do we know the most about? A's. And what's the other variable that we know a little bit about? The B's. Yeah, so let's pair up the A's and the B's, and this should allow us to find big B. We know little b already, so this should help us find angle B. Here we go again. I've got 125 over sine of 115 degrees equals little b, which is 175 over sine of big B, which I don't know. Alrighty, here we go. Cross multiply. I'll have 175 sine of 115 equals 125 sine of big B. Now I need to start this by dividing by 125. So on my calculator, I've got 175 sine of 115. I'm going to hit enter after that, divided by 125, and keep that number on your calculator screen. I did the ... again because we're not finished. What do we still have to do to both sides? Inverse sign. We still have to inverse sign both sides. That is going to cross those out to leave me with big B. Now on my calculator, I'm hitting second sign and then second negative sign. That just puts the answer back in there for me. Now, has anybody already done that? What'd you get back? An error. Yeah, it may even say domain error. It can't do that because this number is not in the domain of inverse sine. We went through those domains a long time ago, but that is not in the domain, which means angle B could never exist in a triangle like this. This is a triangle that's just not going to work. And so, lucky for us, we get to just stop and say that there's not going to be a solution. You don't even have to attempt to find the other variables. If you get an error, then it just can't happen. So no solution on number 3. All right. Now, I'll go ahead and put the assignment up here. And I've got a note down here at the bottom, which I'll explain in a second. But it's T46 from page 410. We'll do 7 to 23 odd. Please don't just copy the answers from the back. Actually show your work. Show me how you set it up with these formulas. But you can skip numbers 15 and 21. You don't have to do those two. And I'm just reminding you down here, sometimes they'll give you the triangle, sometimes they won't. If they don't give it to you, you can just draw it like this, even if it's not drawn to scale. It doesn't matter. It's just kind of helping you see where those variables are.